Hi all, welcome to my channel Know About Embedded System. In today's video, I'll be discussing about two important things. One is interrupts and one is polling. So what is interrupt and what is polling, how they are taking place in our embedded system and what is the significance? That part we'll be discussing about in this video. And if you are not subscribed my channel till now, please do the subscribe and motivate us to create videos like this. So this is what I have shown you with the diagrammatically. So processor, what it will, the blue color diagram what you are seeing, this is your main program. Processor will start execution and it will do the initialization, and processor will start executing your main program, and continuously processor will be executing main program, but in the middle some of the peripherals will request for the interrupt service. So here, this part what you're seeing, this is an interrupt request requested by the some XYZ peripheral, and upon receiving interrupt request, processor will halt the current execution, and processor will jump to the interrupt service routine, executes the interrupt service routine, and after completing ISR execution, the processor will return back to the main program. This is what the diagrammatically we can understand what is an interrupt and how the interrupt service routine executes. So with the definition, so this is how it is defined. Interrupt is a signal generated by the peripherals to the CPU whenever peripherals need a service. This is what I have explained just before this diagram. So whenever you have a peripheral, whenever the peripherals require a service, the peripherals will send a interrupt request signal to the processor. And as the CPU, like once upon receiving the interrupt request from the peripheral, the CPU is nothing but your processor. The CPU then temporarily suspends the current execution. Main program will be temporarily halted. It's going to suspend the current program and saves the status and current address to the stack. So the processor will save the current status information into the stack, because it has to come back. That's why processor required its backup. That's why the CPU will save the status into the stack. Then CPU program counter. So program counter will be loaded with ISR address. So this is my ISR. The program counter will be loaded with interrupt service routine address, and processor will jump to the ISR and jumps to the ISR and it will execute. The processor will execute the ISR. So after execution of ISR, CPU will retrieve the contents of stack and whichever the data which has been pushed into the stack, that content will be popped back into the status register and program counter and starts executing the main program where the processor got interrupted. So this is how interrupt in a brief and in a systematic way we can define with respect to the interrupts. This interrupt process will be applicable for process and microcontroller both. So what is polling? That we will see with respect with the help of diagram. What do you mean by polling? Polling means processor will continuously monitor the peripheral. Processor will not do anything. Processor will continuously monitor the peripheral, whether peripheral required any service. So meaning is processor will not do anything, any execution, but instead of that, processor will continuously monitor or continuously checks the peripherals whether any peripheral required any service or not. Here you can see the processor, if there is no service, you can see here, check the device service, whether any peripheral required any service or not. If not, it will go back here, again it will check. So this process, it will be running within here only. Continuously, the processor will be executing here only. Your processor will be in a continuously infinite loop, continuously checking the peripheral. Okay. And if any device required any service, then serve the device. Serve the device in the sense processor will execute some set of program or some set of code, and again it will go back, again it will check. Now you can see here, from here the processor will go back, again the processor will check the same procedure again, whether any service required or not. So this process is called as polling. Polling means processor will continuously check the different peripherals whether any peripheral required service or not. If not, again go to the next device. Go to next device, check whether device 2 is required service or not. If not, go to 3, go to 4, and it goes on like that. If no device is requested, again it will come back, again it will start monitoring or checking. So this process is called as polling. I hope this is clear. Now let us go to the definition, how it is defined. In polling, CPU continuously checks the status of IO device to determine if they need any service or not. Try to understand the statement here. So this is very important. This is the important definition of your polling. So polling means continuously monitoring a device, or you can say peripheral, device or peripheral, whether any device or any peripheral require any service or not. Okay, and the second point, try to understand here. So this will be done periodically, not one time. The polling involves CPU checking the device in a regular predefined time. So it will be running in a millisecond, maybe 10 millisecond, 100 millisecond, or 1000 millisecond. For every 100 millisecond, the processor will check the device. And this polling concept is based on the protocol concept. That means predefined conditions are defined, or predefined mechanism is defined in the protocol, and based on the protocol, the software coding will be done. Based on the protocol principle, based on the software coding, we can do the polling implementation. So if any device or if any peripheral required a service, so whenever a peripheral is required a service, immediately processor will provide the service. This point. So this point talks about this. So whenever peripheral is required a service, immediately processor will provide the service, and again processor will go and continuously monitor the peripherals. Okay, so this process is called as polling. Okay, but one example I have taken here for this polling, checking a character received or not in the serial terminal. So if you are connecting any serial communication terminal or serial communication process, whether you have received any character or not. If you received, do the processing and go to the next character. If you are not received, do nothing. Okay, so this complete process is called as polling. Okay, so checking a character on the serial terminal is one best example. Like this, we can give a number of examples that I'll be explaining in the upcoming videos. Important thing, that is the difference between polling and interrupt. So most of the interview questions will be coming from interrupt and polling. So sometimes they'll ask about the differences. So what are the differences? If you know polling and interrupt, that is only from that only you can make out the differences. First of all, you have to define the definition. So what do you mean by interrupt? The peripherals will give a notification signal. Our peripheral notifies the interrupt signal to the CPU whenever they require a service. So what do you mean by interrupt? Peripherals will give, or peripherals will peripherals will notify to the CPU that they require some service in an interrupt case. But in case of polling, CPU, nothing but processor steadily checks whether peripheral requires service or not. So in case of interrupt, peripherals will request. In case of polling, CPU will check. Okay. Interrupt is a hardware mechanism. I told you already. Interrupt is a peripheral or hardware based mechanism, whereas polling is a protocol and software based mechanism. Interrupt, third point, if you see, interrupts are serviced by interrupt handler. Interrupts, the service will be provided by the service handler, or it's also called as interrupt handler. Polling, in case of polling, peripherals are handled by processor itself. Okay, that is the difference. And in case of interrupt, there will be no loss of time, and there will be interrupt can occur at any time. There is no any restrictions. Anytime it can occur. But in case of polling, continuously CPU is going to monitor the peripheral with a predefined interval. So that is what I told in the previous explanation. Polling will be done in a predefined time, maybe 10 millisecond, 100 millisecond, 500 millisecond, like that. But in case of interrupt, it's not like that. At any point it can occur, or it may occur, or it may not occur also. Okay, next point, in the interrupt, processor, it's a disturbance to the processor once there is an interrupt. For processor, interrupt is nothing but a disturbance from the external device. Okay, but in case of polling, processor will waste countless time by repeatedly checking the peripherals. Okay, so that means it's a disturbance for a processor in case of interrupt, but in case of polling, your processor is going to check continuously. In case of CPU, it's in case of interrupt, CPU will not waste any time because CPU will be working with a main program. And in case of polling, most of the time will be wasted in monitoring the device or monitoring the peripheral. So in case of interrupt, if there are multiple interrupts are occurred, so that's what you can see here. If the multiple interrupts are occurred, based on the priority, CPU will serve the interrupt with the help of interrupt handler. Try to understand, this is very important question point here. So whenever multiple interrupts are requested, then CPU will serve based on the interrupt priority. We have to assign some priority. So based on the priority, interrupts will be handled. This is in case of interrupts. And in case of polling, so there is no any interrupt priority mechanism, but instead of that, the multiple devices in polling, the CPU will continuously monitor multiple peripherals based on round robin fashion. So these are all the major differences between interrupts and polling. So if you like this video, please like and then subscribe my channel. Okay, so I'll come up with the next video. Until then, thank you.